Hey everybody, this is Mr. Smith with your algebra lesson of the day. Let's go ahead and dive right in. Today we're going to be talking about solving equations. Here's our goals for the day. We're going to understand the definition of a solution to an equation, and we're going to understand what a solution to an equation actually is. And there's your handy dandy standard, if you want to look that up. Okay, we have two vocab words for the day. I want you to write these down somewhere. First off, a solution to an open equation is a value for the variable which makes the equation true. And we'll get exactly into what it means to have a true equation in a moment. Substitution is removing a variable from an equation and replacing it with the variable's value. So check out the example here. If we have the equation x plus 2 equals 8 minus x, we can see that we would get a true equation if we substitute in x equals 3, because 3 plus 2 is the same as 8 minus 3. However, we get a false equation if we substitute in x equals 4, because 4 plus 2 and 8 minus 4 are not the same. Now, I don't know about the last time you've been on a seesaw, but hopefully you had a better go than some of these folks. I don't want to laugh at the misfortune of others, but I mean, oh my gosh. Now, why do we laugh at the misfortune of others just now, talking about a seesaw? Here's the thing with a seesaw. If it's perfectly balanced, things are hunky-dory. Oh, but what happens when it's not perfectly balanced? Things get awry. Now, your seesaw is much like an equation. We want both sides of the equation to be balanced, just like both sides of my seesaw are balanced as well. Those poor people didn't have the balance. So check this out. We have this equation here, 3x plus 1 over 4 equals 5 over 4. And we want to test to see if 2 is a solution to that. So we're going to substitute. So what we'll do is we're going to substitute in 2 for x. Get my annotating pen here. Here we go. So what we're going to do is substitute in the 2 there. 3 times 2 gives us 6. Add the 1, and we get 7 on top. 4 is still hanging on the bottom. Now, check both sides. Check 7 over 4 and 5 over 4. If they're not equal, it means that teeter-totter is unbalanced and somebody's fallen off. So since that is not balanced out, it is not a solution. Let's keep going. We'll unannotate here. There we go. All right. So check this out. I'd like to draw a handy dandy red line right down the middle of my equation and make sure this thing is balanced out. Now we're going to take a test to see if -3 is an equation for this bad boy here. So remove the variables, substitute in the value you want. There's my -3. So we're going to take on this side, -3 times 3 plus 1 is -8. On this side, 4 times -3 plus 4 is also -8. Since both sides are the same, it balances out. That teeter-totter is well balanced, and it's not dumping anybody on the ground. So now I wouldn't just leave you hanging here. After showing you 1 and 2 examples, I'm going to have you try one on your own. So check this one out here. That annotation looks strange with nothing around it, so let's clear that out there. All right. All right, so I want you to try this one on your own. I'm going to watch, use the chat box to ask questions.